Hello everybody, my name is Tommy and welcome to Air Workshop. You join me in the office here today as I'm going to share with you how I created the spoilboard for my CNC using Vectric software. Now this video will probably make a little bit more sense if you've already watched the video of me making the spoilboard on the CNC. So I will leave a link to that in the description of the video. The methods I use in this can be used across the board, no matter what size your spoilboard is. The methods will still be the same. The dimensions will be different, but the method will still be the same. So in this, I'm going to be covering how I generated the holes and all for the T-nuts. I'm going to show you how I surfaced the spoilboard, and I'm going to show you how I designed the grid lines for the spoilboard. So the first thing I want to do is actually set out for the grid lines in a single section, and so that I can set out for the T-nuts. So let's just jump on the computer and let's get started on the T-nuts and the grid lines. So to get started, I'm just going to create a new file, and I'm going to put in the dimensions of the piece of MDF I'm using for a section of the spoilboard, which is going to be 1370 wide and 400 high. It's going to be 18 millimeters thick. I'm going to be probing off the surface of the material, and the XY datum position, because this is 1370 and the machine will only machine 1270, I'm outside the machine limit, so I can't probe off any of the four corners. So I'm going to be using the center of the material for to set up the piece in the machine, so that I can still work back the 1270 each side, and that's the piece of material set up. Now I'm going to be concentrating on a section in the middle that's 1220 wide, which is the width of a 4-foot sheet of material. And because I'm going to be adding a little rebate to both edges of this that are going to be 6 millimeters, this is really going to be 388 millimeters. But I want to set out in this for 48 T-nuts in the center of this, and I will also be adding some grid lines to it. So to set it up, I think the simplest thing to do is actually add the grid lines now, and I can come back to those later on when I need them. So to do that, I'm just going to draw a line, and I'm just going to draw a line anywhere vertically, just making sure that I keep it to 90 degrees like that. Doesn't matter what length it is. And I draw another one across, just keeping sure that it's at 0, so we know that it's right to the machine. And now with that selected, I can go into transform objects and set selected object size, and we can make that line 1220 long and apply. And then I can select the other one, and I can make that one 388 millimeters long and apply. And now I can close that. So that line is still selected. So now I want to have 13 of those lines across the piece of material, and that'll give me 12 gaps across. So I'll have a grid pattern in or around 100 mil by 100 mil is what I'm aiming for. So if I go in to array copy on that, I want one row in the Y, but on the X I want 13, and I want to set an offset on that, and it'll be 1220 millimeters divided by 12, which is going to give me 101.67. And then I can just hit copy, and that's going to put all the lines across the sheet. And if I just close that for a second, and if I go into transform objects, align selected objects, and I just center those in the sheet. So now I know that they're equally spaced across and that they're up and down from the top and bottom the exact amount. And we select the other one and we do the very same thing, only this time I want 5 rows high and I only want 1 column. And the offset on this one is going to be 388 divided by 4, which is 97 millimeters. And I can again copy, that places them in, close that, and again we can center those to the material. And now that the grid lines are in, I can close out with there, and if I hit that, now I have the grid pattern, so that now once I start to put in the T-nuts, it actually makes sense as to the area that I'm working with. So I don't need the grid lines at the moment, but what I am going to do is I'm just going to select the lot of them, and I'm just going to group them like that. And that means that the whole lot will be selected at one time, so that if I need to select them and later on, I'll be able to just grab that without selecting the T-nut holes. So now what I want to do is I want to add a hole to the center of each of those squares. And that is going to have a hole the whole way through for the T-nut, an M6 prong T-nut. And I also want to put a recess to allow the T-nut to sit into the material. So again, I just go up and I just draw a circle, and the hole that I want the whole way through for a 7mm T-nut is going to be 6.75 to make sure that it's a good tight fit. And all I do is just pop down here and just drop it in anywhere, it doesn't matter. And that's now in there. If I zoom in, that's there. And I also want one that's going to be 17mm for the recess. And if I go in and just pop down, you'll see the crosshairs. And if I click there, that is now centered on the first one. So I can close out of there. And if I zoom back, now those are there, but they're not centered in that box. So I just select both of those. I'm going to again go in to do an array copy. And as you can see, the gap on, or the offset on the X and the Y is still there from when we done the grid lines. So now all I need to do is just set the amount of rows and columns of them that I need. So I am going to need 4 rows high, and I'm going to need 12 rows across. And if I zoom back and if I hit copy, that puts all of those in to the piece like that. And again, to get those centered in that, I just align selected objects and center in the material. And now all of those are set in the center of all the grid lines. So with those now done, I just need to create the toolpath, and I'm only interested in the hole and the recess for the T-nut. So we just go across, we switch to the toolpath. And what I'm going to do is I'm just going to select the center hole in the bottom left hand corner here. And I'm going to create a pocket toolpath. And the start depth is going to be 0 because it's top of the material. The material is 18mm, but I want to go through the material. So I'm going to set that as being 19mm. Now, I am going to be using a 1/4 inch end mill. That's what the machine will use the last time here. But it's going to be an upcut bit, so that'll be okay. Now, when it comes to passes, I'm not wanting to do it in 4 passes because that'd be a probing action. Now, because the hole is actually slightly bigger than the bit, I'm going to do it in 1 pass. So I just go in and I select 1 pass. And it's going to be conventional, but I am going to add a ramp. So you can add ramp plunges here. I'm going to add a ramp, and I'm going to leave it at 3mm. That's what it's already at. So that means that the bit will actually spiral down through the hole. It won't plunge down just in one plunge. It'll actually spiral down through the hole. And that's it. So I can just hit calculate. It's going to give me a warning to tell me that I'm going through the material. So I know that. So I can just go OK. And that's going to have that hole there. So if I just go back to the 2D and then I select the outer hole, close there, and I go in and I do a pocket toolpath again. But this time I'm only going to be going 2mm deep. I'm still using a 1/4 inch end mill. And I'm going to leave the pass, it's only going 2 mil deep, so 1 pass is okay. Conventional cut. Come down, the ramp plunge move, I can leave it, it doesn't matter, it's only going 2 millimeters deep. And we can calculate that. So now I have both pocket toolpaths there. So if I just want to preview that, I can just select both there and preview all toolpaths, and the hole is there and the recess is there. So again, as before, I can now, instead of doing all of those individually, I can go in and I can do an array copy toolpath, and I can select both of those toolpaths, which will put them in there, pocket 1 and pocket 2. And the settings that I've had from when I done it in the design section is still here. So I have 4 rows, 12 columns, offset, and the measurements are in there. So I can just calculate that, and that's going to put all of those in. And once again, I can go in and I'll just slow it down because it goes very fast. And I can preview that selected toolpath, which is the array toolpath, and that's going to put in the recess and the hole in one action, and as it moves across the board, it's going to do the hole first and then it's going to do the recess. So the last thing I just need to do is close out of there, is I need to select the array toolpath and go into saved toolpath. And in here it'll tell you that you need a 1/4 inch end mill to do this toolpath. I have the machine selected as being the workbee Z1 plus 1500 by 1500. So now it's just a case that you just save the toolpath, name it what you want to name it. I have already saved the program here as Spoilboard section T-nuts. So I would probably call this Spoilboard section T-nuts 6mm, and that then saves the G code. So I can upload it onto a USB drive and bring it out to the CNC to do the cutout. So with the main section of the T-nuts now done on the spoilboard, I want to create some on the outside of the spoilboard, on the edges, outside the machine limits. So I'm just going to show you quickly how I done that. So I want to add 4 more T-nuts outside the machine limits in the ends of the spoilboard. So to do that, I may just draw up a small section of the end of the spoilboard so that I can flip the spoilboard 90 degrees in the machine to machine those out. And I'm going to select the hole and the recess here closest to the XY datum position, and I am just going to select copy, and then I am going to go up and I'm going to create a new file, and I'm going to change the width now to 400, which is the same as the spoilboard. The height doesn't matter, but because now I'm going to be able to get to the corner here, I'm going to change the XY datum position to that corner. So that's okay. And because I selected the holes that were closest to that XY on the other drawing, when I go paste, that's going to come in the same position. But that's not the position I wanted because it's a little bit further away from the end of the sheet. So with those selected, I can go in and I can actually move the selected object, and I can set the position off the end of the sheet. So that will be on the Y. So I can change that to 30mm and apply, and that'll bring it down to the center of the hole is now 30mm off the end. So we can close that, and as before, we can just go in and array copy, and I only want 1 row high, and I want 4 across the bottom of the sheet as an offset. The measurements are still in there from the last time we done it, and then it's just copy, and we close out with that, and again we just center those across the sheet like that. So that's the 4 of those now done in the end with the XY here. So with those done again, it's just the very same thing. You pop over, we can select the center, do a pocket toolpath that's going 19mm deep, and the end mill is 1/4 mil. Set this back to 1, and we're going to have the ramp, and we can calculate. It's going to cut through, okay. And then we can go back, select the other one, close that, and do one 2mm, and calculate that. And again, we can array, copy toolpath. We'll be going 1 and 4. Measurements are still in there. Calculate, that puts all those in. And we can now preview the toolpath. So that's the very same thing. So then it's just a case of saving your toolpath again so that you can machine those into the end of the spoilboard. So the next step I want to take is actually to create a surfacing toolpath so that I can level the top of the spoilboard so that I know that it's 100% perfect without any ups and downs in it, that it is level so that any piece I put on it is going to be the same regardless of where it's positioned on the spoilboard. So we'll jump into that now. So once again, I'm going to go in, create a new file, and I'm going to set the job size, the exact size that I'm wanting to actually surface. So I'm going to set that as 1240 in the width and 1220 in the height. And I am going to be changing the XY datum position back to the center, because for my setup, it's an awful lot simpler to work from the center. And we'll just go OK. Now, I just want to draw a rectangle the same size as the spoilboard, and the measurements are already in there. So we can just create, we close that, we select that, and we just center that on the sheet. So we can close, and that's the design end of it done. So it's just over then to create the toolpath. So I'm going to be creating a pocket toolpath. I am going to set the depth as being 0.25 of a millimeter. I'm not going very much. I think it's better to go in small passes than trying to take too much, because the spoilboard might not be as on level as you think. We can always run 2 or 3 more passes if need be. I'm going to get rid of the 1/4 inch end mill, and I am going to select my 1 1/8 inch surfacing bit, and the passes can stay the same. I am going to run it as an offset, so it'll be starting in the middle and working its way out, but I am going to change from a climb cut to a conventional cut, and it doesn't need to be a ram because it's only 0.25 of a millimeter, so we can calculate that. And with that selected, we can just preview the toolpath, and as you can see, it's just running the passes from the center out to the outside of the material to create the light flat spoilboard. And then again, it's just a case of, once again, saving the design and saving your toolpath and bringing it out to run in the machine. So now that I have a level spoilboard, the last thing I want to do is to add all the grid lines to the 3 sections on my spoilboard. So now we're going to jump back in, and I'm going to show you how I went from the single set of grid lines that I done in the first design to create the 3 sets of grid lines to cover the 3 sections of the spoilboard that I have. So to start with the grid lines again, I'm back to the original drawing that I done to start with, and I'm going to select the grid lines, and I am going to copy those. And then I am going to go and I'm going to create a new file, and I'm going to set this up as the overall size of the spoilboard that's on the machine. So that will be 1370 wide, and from the front edge to the back edge of the 3 sections of spoilboard is 1218. And I'm going to be using the XY datum position for this, so we can just go OK. So now I can just paste those grid lines onto the board. Now, before I go any further on this, because I grouped those at the start just so that I could bring them across like this, if I was to set up a toolpath for those, which I will do quickly now, so I'm going to create a profile toolpath, and I'm going to go 1.5 millimeters deep with a 60-degree V-bit on the line, and we just calculate that. As you can see, there's an awful lot of red lines, and the red lines is the machine moving without cutting. So if you preview the toolpath, you'll see that it's kind of erratic the way the grooves are cut. It's not optimized. So what I like to do is go in, and we go back to the design, and I've that selected, but what I'm going to do is I'm going to ungroup those, and I'm going to select them by holding the shift key as I go, and I'm going to select them around in a clockwise direction to do the outside first, and it's coming around. So the next line it'll do is this one, then it'll do this one, and then it'll do this one. And once that one is done, we're over here. So I'm going to then select from there back across the board. Like that. And then I'm going to regroup them. So now once I go back to the toolpath, I can just open that profile toolpath. All the settings are there. I select the grid pattern again, and then I calculate it again. And now it even looks worse. But what I should have done was actually, when I was in the profile, went in and selected order and vector selection order. So if I click that, it'll work off the fact that I selected those, and now you can see we're starting from the middle and we're going out and we're running around. So if I preview the selected toolpath, you can see it's going in the exact order that I done it, which is using up less time on the machine. So with that done, we go back to the drawing, and I still have that selected. So now I'm going to want 3 of those to do the 3 sections. So I'm going to do an array copy, and I want 3 rows and 1 column. But I want a gap on this between the 3 sections on the Y. So I want a gap of 27 millimeters, because that's the fillet piece that I put in to hold down the sections. That can be 0. It wouldn't matter because we're not going that direction anyway. And I go copy. And that puts the 3 in with a 27 millimeter gap between them. So then again, I can just center those on the material like that. And now they are in exactly level with the front and back of the edge that we had said at the start, and it is centered on the material in the width. So once I go back to the toolpath and I click on the profile toolpath again, I have that one selected. I just hit shift and I select that one and that one, and then do the calculate again. Now it'll do all 3. So I just reset the preview from before, and now I can preview the toolpath, and it will do the 3 sections of the grid on the 3 separate parts of the board, the spoil board, all in the one go. And as before, then you just save the program and save the toolpath in whatever folder and all you want. So that's how I designed the spoil board for my CNC using the Vectric Aspire software. I'm still learning the software, but I think the methods I've used are probably some of the quickest you can use to actually do a spoilboard. So hopefully that you've learned something from this, and maybe even if you don't have a CNC and you've watched this, you might be able to see just what it takes just to get a design onto the CNC and get the thing running. So that's where I'm going to leave it for this video. Like I said at the start, I'm going to leave a link in the description to the video where I machined the spoilboard and fitted it to the machine. So if you want to check that out, if you haven't already done so, the link will be in the description of this video. So if you liked this video, maybe you consider giving it a thumbs up, and if you haven't already done so, maybe you might consider subscribing to the channel. Won't cost you a penny. So all that's left for me to say is thanks very much for watching, and I'll see you again soon. Good luck.